So this is going to be a pretty short lecture videos. So in this whole chapter, chapter 7, we talked about computing confidence interval, right? And the idea behind confidence interval is that we're kind of estimating our population mean or population proportion within some sort of interval or range. And essentially there's two ways we could compute it. We could use the Z method or the T method. And again, just a reminder, the T method is just that we use the student T distribution because we don't know what our population standard deviation is. And the Z method is that we know what our population standard deviation is, and that way we could just use the Z method. So in this section, we're just gonna follow a chart to kind of identify which method to use. So here, again, just to recap, we're essentially want to know what parameters are we estimating, and so far we did two parameters: population mean mu, or the population proportion p. So let's focus on the population mean first. So here, there's two methods for constructing a confidence interval with the population mean. Again, the Z method and the T method, and these are the corresponding sections that you might want to go over again. And to determine which method we use, we must determine whether the population standard deviation is known and unknown, and whether the population is approximately normal, or whether the sample size is large enough, aka greater than 30. And here, the population proportion, when we are dealing with proportion, that kind of gives you an idea like, oh, we're using the method that we learned in section 7.3. So here's a little chart that might help you out to identify which method we're going to use. So the first thing you want to ask yourself, the very first thing you want to ask yourself is the population standard deviation known? If it is, great. Then you want to ask yourself that, is your sample size greater than 30? If it is, then that gives you an idea like, oh, I got to use a Z method. But what happens if your if your sample size is not big enough? It's not greater than 30. So it's not. Then you want to ask yourself, is the population approximately normal? If it is, then yeah, you could use the Z method. But if it's not, then you have to talk to a statistician. And there's other methods that we have to use, which is a lot harder than what we're going to talk about this whole semester. Or you could just say like it's not possible. Okay, so what happens if you ask yourself, do I know my population standard deviation? And the answer is no. And then you ask yourself, is your sample size greater than 30? If it is, then this gives you an idea like, oh, I need to use the T method from 7.2. But let's say your sample size is not greater than 30. So it's not. Then you want to ask yourself, is the population approximately normal? If it is, then use the T method. If it's not, then again, you have to talk to a statistician. And for the proportion one, it's kind of easy to identify since they're talking about like somewhere in the question is going to say proportion. Then that gives you an idea of like, oh, I got to use a method from 7.3. So let's do an example here. So here you want to determine which method we're going to use. So here, a random sample of 41 pumpkin harvest from a pumpkin patch has a mean weight of 8.53 pounds with a sample standard deviation of 1.32 pounds. Here we want to construct a 95% confidence interval for the mean weight of pumpkin from this patch and determine the type of parameter that is to be estimated and construct the confidence interval. So let's kind of gather all the information that we know. We know that our sample size is 41 because we had a random sample of 41 pumpkin. They give us that the mean weight here is 8.53. So the mean weight is just 8.53 pounds. They also tell us that the sample standard deviation S is 1.32 pounds, and our goal was to construct a 95% confidence interval. So let's pause for a moment here. What would you say, which method are we going to use? You could just take a guess. Well, if you go up here, do we know our population standard deviation, which is our sigma here? Do we know this value? And the answer here is no. We have a sample standard deviation, but we don't have the population standard deviation, sigma. So here, the answer is no. Then is our sample size large enough? Is it greater than 30? Well, we know that our sample size is 41, so it is. So, we're going to use the T method here. Let me use a different highlighter. T method. So that's what we're going to use. So here, and then the little note here, we will use the T method. Great. Now that we know which method to use, we can actually continue constructing the confidence interval. So again, with the T method, we need to know what our degree of freedoms are. And the degree of freedom is just n minus 1, or 41 minus 1, which is 40. And the reason why we need the degree of freedom is so we can compute our critical value, T of alpha over 2. So we look at our table here. So this is just the critical value from the student T distribution. And again, it's on Blackboard. If you want to use it, you have to use it. So you go at 40, which is degree of freedom. And since we're dealing with a 95% confidence interval, we know that our critical value is 2.021. So this here, our critical value will be 2.021. So we could compute our margin of error, which is just our critical value, times the standard error, S over square root of n, where S again is just our sample standard deviation, and n is our sample size. So this will be 2.021 times 1.32 all over square root of 41. And this is going to be equal to 0.41978. So now we could actually construct our confidence interval. So this will be x bar minus e is less than mu is less than x bar plus e. And again, this is just saying that our population mean is within these two values. So I'm just gonna skip a couple math here, and this will be 8.11 is less than mu is less than 8.95. So here is our confidence interval. But again, the one thing that we actually care about is how to interpret this. So we could say that we are 95% confident that the mean weight of pumpkin from this patch is between 8.11 and 8.95 pounds. Cool.